Hi everyone. Today we have with us Patrick Spicer, who is an associate professor of chemical engineering at the University of New South Wales in Sydney. And we are very, very much looking forward to listening to Pat talk about this new term that I have learned myself, which is thunderstorm asthma. So, Pat, first of all, welcome. And could you define what exactly does thunderstorm asthma mean?
Okay, sure. Thanks. Thunderstorm asthma refers to a condition that has primarily occurred in, or at least in good records, within Australia and the United Kingdom. And what happens is when a thunderstorm or some atmospheric event passes through an area and people have a very broad array of respiratory problems, typically characterized as some form of asthma. And what's most remarkable about this, and one of the things that really galvanized me to start looking at this, was an event in Melbourne, Australia in 2016, when so many people without any history of respiratory problems exhibited asthma symptoms, had problems presented at emergency rooms, exhausted the inhaler supply for most of the hospitals, and a number of fairly young people with no history of respiratory problems actually passed away as a result of this. And so the mechanism is not fully understood, but a presence of pollens like grass pollen, typically in the warmer period, and a very strong thunderstorm activity typically correlate with this sort of outbreak and condition.
Okay, that sounds really dangerous. And it's quite self-explanatory why it needs to be cured, but could you talk a little bit about why people should pay attention to it and be mindful of it, and there should be more research in this field?
Sure. Well, certainly it's something that's very unexpected, and especially when it affects people who typically have no history of this sort of thing. So it really speaks to how extreme the condition can be. And I will add that I'm quite new to this field, but I came into this because of this event that happened in Australia. I was just so struck by the suddenness, the ferocity of it, and the real difficulty in predicting it that I just couldn't stop thinking about it, and it got me interested in this. But really, the reason people are working on this is particularly with a desire to, if they can't prevent it, to be able to predict it. What are the conditions that lead to this sort of thing happening, so people can be given accurate and adequate warning and be protected against this, especially people who are vulnerable.
Okay. You mentioned that this is a problem, or this is a condition that is observed in the UK and in Australia. Is there a reason behind why it only appears in these two regions and not in the US or in Europe, rest of the Europe?
I don't know fully, and I think I think certainly other countries are affected by this sort of thing, but often it's just the concentration, and certainly the dry conditions or the conditions for the growth of the grass and the production of the pollen that comes together to happen. I think there's actually a good Wikipedia page on this that lists a number of other incidents that have been recorded. So I think these is one of those things that people are going to be more aware of and realize can happen, but it's just not something that you necessarily expect to happen. And so part of this is it's just like what people are doing with the coronavirus right now. Every day you get more data and you have more of a mature perspective about what might happen, but we're still learning a lot. And that's very much the case with thunderstorm asthma as well.
Okay. Yeah, that sounds fair. So what's your approach? How are you researching this thunderstorm asthma? How are you going about it?
Well, when I first heard about it, my PhD was with a group that did a lot of aerosol work. And people who work with aerosols can do it for environmental health and safety reasons or for material science reasons. And we worked with a lot of people around that kind of thing. And so that had my ears pricked up when this sort of thing happened, because I realized this was a really unusual event, even within the context of a lot of other things that can happen around inhalable particles and things like that. Um, so, really that got me moving down the path of looking at where this might happen. But I had to get a bigger team. And so I have really good colleagues who work with medical aerosols at the University of Sydney. And so I started chattering away to them really early into this process. And they found an expert who's probably one of the key experts in the world on pollen and some of these health implications at the University of Queensland. So Janet Davies at Queensland and Daniela Traini at the University of Sydney. And at the time, PJ Cullen was at UNSW, and he's an expert in plasma discharge and cold plasma devices. So we said, well, we can look at particles, the pollen, the thunderstorm, and really the lightning charges that could be affecting the surfaces of these particles. And Daniela's group at the University of Sydney looks at culturing tissue and cells from nasal passages and your throat, your lungs, and looking at inflammatory response. And so we really said, okay, we can really put all this expertise together and try to duplicate some of these conditions that happen during a thunderstorm, and also then verify what are some real criteria for when this could happen, and really try to help warn people and mitigate it.
Okay. Yeah, it sounds like a lot of work, and I'm very happy to hear that several different groups are already working on it, and they are already trying different approaches to finding finding out more about it. And the more you find out about it, the more you can actually start planning and researching how to actually cure it, or how to treat the symptoms at least. And speaking of that, what do we expect? Is there like a timeline that, okay, in 2 years we will hopefully be able to reach this milestone or something like that? What is coming next from the research point of view?
Yeah, well, so our team was funded to look at this by the Australian Research Council. We got a discovery grant to focus on the mechanisms behind this phenomenon. This was really stimulated by the idea that a lot of the things going on now, or a lot of the current model of this behavior, is still hypothetical. And some of it is quite hard to test, obviously, because it's happening under very extreme conditions. So we are almost exactly halfway through a 3-year project on this. And so where we are now is we have a number of pollen samples, and we have cultured cells, and we are really looking at some of the surface treatments, very extreme sort of lab lightning discharge treatments, but also some of the very extreme variations in humidity and temperature and flow that these things undergo. And so we're at the stage right now where we've made a lot of headway into directly observing pollen grains rupturing under incredibly extreme and rapid transport conditions, and using the output of that then to start looking at how does this get into the body, how does this affect cells in the body when it contacts them, and how can we then start to use those conditions to tell people this is when this might happen, but also talk to people about the range of responses that the human body goes through when these cells come in contact with them.
Okay, that sounds
so really. Sorry, you asked what time frame. I didn't answer you. I was just going to say we've got another 1.5 years, so we should be pretty far into things by then.
Okay, wonderful. Looking forward to that. I do have a question regarding, you mentioned that you observed these pollen grains change their properties or change in some way under these extreme conditions. So what exactly does change, and how do you observe it from the characterization point of view? Do you look at it under a microscope? Do you look at it under an electron microscope, or what exactly do you do?
Yeah, no, it's a great question. My research is primarily focused around imaging techniques. So we do a lot of microscopy to look at this kind of thing. And fortunately, pollen grains are large enough for us to see with optical microscopes. And so what we have done is develop some cells that, very much like microfluidic cells or some of the small flow channel testing cells, where we can think about the conditions that the pollen experiences in the cloud, right? The thunderstorm asthma is thought to come from when an updraft in a thunderstorm pulls a lot of pollen up from dry grassy areas. The pollen goes into the very, very humid and active thunderstorm. And because of its hydration, which it does naturally, when you hydrate pollen, it swells and it can rupture, and it releases a lot of proteins and particles that are part of its reproductive process. Mm-hmm. But that is thought to be the culprit in thunderstorm asthma, is the allergenic response to some of those things that are released from the pollen grains. Mm-hmm. So really what we're doing is looking and doing direct observations of this happening. But because it happens so quickly, what we've done is reverse the process. Instead of moving the pollen into the humidity and the conditions, we fix the pollen under the microscope and move humidity and temperature through really rapidly in the system. And under high-speed imaging, we observe the rupture and release of these particles.
Mm-hmm. Okay, that sounds really, really interesting. I myself have learned a lot, and I'm really gonna follow up on what's coming from, especially from your group on thunderstorm asthma now. So thank you very much, Pat, for educating us about this new condition, newly discovered condition. Is that fair to say?
Yes, I think it's atmospheric conditions and health conditions all in one.
Yeah, absolutely. So thank you very much. Anything else you would like to tell us about the thunderstorm asthma?
No, I don't think so. I think really the key, as with many things, is having the wide array of expertise and disciplines that are needed. Many of the conditions that we face like this can't be solved by any one field or any one researcher. So I think that's the thing that I've always believed, and this has emphasized for me.
Mm-hmm. Okay, wonderful. Thank you very much again. And as I said, looking forward to reading up more on the topic.
Great. Thank you as well.